Hi, in this lecture you will learn what the compound triggers are and how to use them. Up to now we learned 4 types of triggers. Before statement triggers, before each row triggers, after each row triggers, and after statement triggers respectively. With these triggers we can take some actions before or after the statements or rows. But these triggers all have their own variables, types, etc. So you cannot use one variable or type within another. And sometimes you need something like that. But this was not applicable until Oracle Database 11G released. With starting from that release, we can create compound trigger types. So what are the compound triggers? The compound trigger is a single trigger on a table or view that allows us to specify actions for each HTML trigger types that I mentioned right before. That means we can do all the levels of trigger actions in one trigger. So they can share the variables, types, etc. among each other. As you can see in the schema, we have our variables types on the top. This area is called as a declaration section. We declare our types, variables, etc. here. Then we write our before statement and after statement trigger actions and row level trigger actions after that. So we can use the variables that we declared in the declaration section within all these sections. But notice that we don't need to take actions for all these levels. They are all optional. We can write all of them or some of them. It's up to you. But we need to write at least one. So our compound trigger has 5 sections. We call each of these action areas as sections. So we can do all these events section by section. But notice that our compound trigger starts when the triggering statement starts and continues until the triggering statements complete. So it lives along the time of first section starts and last section finishes. Before compound triggers, we would do that with some other ways, like doing that in some packages, etc. But this was very error prone and we have some memory and performance problems. But with compound triggers, we could do that much faster and safer. So why we use the compound triggers? We use compound triggers to take actions for various timing points by sharing the common data among these timing points. For example, we can declare some variables in it, then assign some values at the before statement section or any other, and then we can use it in another like after row trigger or any other. This might be useful for so many times. To make inserts to some other tables faster with using the bulk inserts. Actually, we haven't seen the bulk inserts yet. For now, I can say that instead of inserting rows one by one, we use bulk inserts to make that faster. So your compound trigger will enable you to make faster inserts to the other tables. You will understand better when you see the bulk inserts in the performance section. In the next lecture, you will see what the mutating table errors are. This is a common error in triggers, and without the compound triggers, we cannot handle that problem easily. We will see that in details in the next lecture. To sum up, compound triggers have 5 sections: initial section, before statement section, after statement section, before each row section, and after each row section. These 4 sections are optional. You can write all of them or some of them, it's up to you. Besides, we can have compound triggers with the views too. But this time there are 2 sections, initial section and instead of section. Actually, this is not a frequently used compound trigger type, because we can use the instead of triggers instead. There is no difference. But I mentioned just to show you that you have an option like that. So let's pass this for now. Now, are there any restrictions of the compound triggers? Yes. A compound trigger must be a DML trigger defined on a table or view. So you cannot create a compound trigger as a DDL trigger or something. It must be a DML trigger and can be on a table or a view. A compound trigger body must be a compound trigger block. As you have seen on the schema in the previous page, a compound trigger has its sections written by PL/SQL code. It cannot have something different like an anonymous block, a procedure, or something like that. Actually, you can have your subprograms in the declaration area. It is valid. But you cannot create subprograms after you write your first section. You will understand better when we make the examples. A compound trigger body cannot have an initialization block. As we know, a compound trigger body can have only the sections, so it cannot have an initialization block. You need to do your business in these sections, but it can have the exception section. It is valid. But notice that each section must have its own exception section. An exception cannot be handled in another section's exception area, or you cannot have a common exception area for the whole trigger. So you need to handle the exceptions of a section in itself. So do not forget that the compound trigger cannot have a standalone exception section. You can use exception sections within the triggering sections. Old and new cannot be used in the declaration or before or after statements. We know that old and new qualifiers can only be used within the before row and after row triggers. So you cannot use these qualifiers within the declaration area of a compound trigger or before statement or after statement sections of that trigger. The firing order of the compound trigger is not guaranteed if you don't use the follows clause. There might be more than one compound trigger on the same table or view. As we have learned before, the firing order of the same level triggers is specified by the server randomly. So we cannot say that a trigger that created before the other one will run first. It may change. So you need to use follows clause to order the same level triggers for the fire times. Great. Now let's see how we create a compound trigger. The first create or replace area is the same as the previous triggers. But unlike the other triggers, we don't have any timing area here. We don't write before or after. And for the event area, we start writing them with the for keyword. We can have one or more event types here. It's up to you. So we simply write for insert or update or delete. Then we write on keyword and our base object name, like how we did in the previous ones. Then we can write referencing old as old and new as new qualifiers. And then we can write the when condition. These are like how we did before and they are optional. After that, we write compound trigger keywords. With these keywords, we specify that our trigger will be a compound trigger. After the compound trigger keywords, we have the declaration area of that compound trigger. We directly write our types, variables, etc. here. These objects will be global for that trigger. So you can use these objects at anywhere in that trigger. Besides, you can use these objects with different sections. So you will be able to share the values of these objects by multiple levels of triggering actions. This section is optional. I mean, you don't have to declare any objects here, but you can have as many objects as you wish here. Great. Then we write our triggering sections. I mean, we can write our statement level and row level triggers. All these sections are optional, but you need to write at least one of these sections in a compound trigger. So you need to write at least one, but you can write more. It's up to you. But you cannot write the same section more than one. I mean, for example, you cannot have two before statement sections in one compound trigger. Alright, these sections are the DML trigger types that we have learned up to now. The first one is the before statement section. To use it, we simply write before statement is keywords. Then we write the PLSQL block in it. Each section can have its own variables, types, etc. To declare them, we don't write declare keyword. We simply declare them, just like how we do in the declaration area. Then we write our begin keyword and then we write our PLSQL codes here. If we want, we can write an exception section for that too. After all these, we write end keyword and the type of that section. Since this is a before statement section, we write end before statement here. The rest of the sections are just like the first one. The only differences are the names. For before each row, we write before each row, and it goes on like that, as you can see on the sample code here. After finishing all the sections, we simply write our AND keyword. As I had mentioned, we can have another type of compound trigger. It is using the instead of trigger in it. To create it, we only write instead of each row is in the sections area. But notice that this section is used only with the views. And if you use this instead of section, you cannot use the others with this one. This can be used as a single section. Alright, creating a compound trigger is a bit different than the other trigger types, but not so hard. As you can see, there are a few changes. So it will not be so hard to learn it. Great, now we know what the compound triggers are and how we use them technically. So now let's create our first compound trigger and see it on the action. Let's first start with a simple example just to show how it works. Then we will make it more like a real-world example. We simply write create or replace trigger trg comp amps for insert or update or delete on employees copy. As you can see, we simply write for in our event types. For this example, I want my trigger to work for all the event types, but you can write less, it's up to you. Then we write the compound trigger keywords. Now, let's declare a variable that will keep the DML type, like we did in the previous examples. We will use this variable within each section. I write vdml type is varchar2 and 10. Great. Now let's start with writing the sections one by one. I will write all the sections in this example, but you can write one or a few of them. I write before statement is. In this section, we will assign the DML type into our variable. So we will write our begin keyword first. Now, let's write our if-else-if clause like we did in the previous lectures. If inserting then, let me copy that. Our variable is equal to insert. Else if updating, then it is equal to update. Else if deleting, then it is equal to delete. And our end if. Now let's print that value. DMS output dot put line, let's say before statement section is executed with the value of our variable. And let's write something more event. Now here we write the AND keyword and the type of the section. So I simply write AND before statement. Great. Now let's write our before each row section. Before each row is. As you have learned, we can write the local variables right after the is keyword and before the begin keyword. I will write 1 just to show you that it is accepted. But be aware that these local variables will not be reachable outside of that section. Let's write, for example, x and the type is number. And our begin keyword. Now let's copy that DMS output and paste into here. And change before row section is executed with the VDML type event. And now let's write and before each row. And before each row. Now let's write our after each row section. Let me copy all these and paste in here and write after each row and after each row. And let's delete here and write after row section is executed with the DML type. And now let's write our after statement section. Let me copy that and paste in here and delete all these and write after statement is an and after statement, and let's write after statement section is executed. And we finish the trigger with the last and keyword. Great. Now let's compile and test our compound trigger. Let's write delete from employees copy where department ID is equal to 30. We will delete multiple rows. Now let's run it. As you can see, our compound trigger worked just like we created 4 different triggers. Now, what is the benefit of using compound triggers for this example? We collected 4 triggers in one, so we could use the same variable with all different sections. Alright, now let's convert this trigger into a better example. Assume that we will create a trigger that will check the salaries after the updates or inserts. If the salary is greater than 15% of the average salary of its department, our trigger will prevent that update. Let's simply update our trigger and see how to do that. First, we know that we don't have to write all the sections in our compound trigger. So let's simply delete the before each row trigger, because we will make the check after the update of each row. But we will use before statement trigger to get the average salaries of each department into a collection. Then we will use that collection within our after each row section to make our comparison simply. Then we will print a message in the after statement section to show that all the changes are done successfully. So let's do that. Now, in here, we will create our type for the average salaries of the departments. Our associative array type will have the salaries with the index of department IDs. Let's write type TAVG depth salaries is table of employees copy dot salary person type and indexed by PLS integer. And now we will create our collection based on that type. AVG depth salaries is TAVG depth salaries type. Now, in our before statement section, we will add all the departments' average salaries into our associative array with using their department IDs as the keys. To do that, we will use a for loop with an SQL query in it. So let's delete these and write for AVG cell in our select statement, select AVG salary as salary and NVL department ID I used NVL in here in order not to get an error. So I simply write department ID as the alias, and from employees copy, group by department ID, and our loop. Now we will assign our value to the collection. Let me copy the collection name first. And with the index of AVG cell dot department ID is equal to AVG cell dot salary, and our end loop. Now, as we have learned before, these sections can have their own local variables. So let's declare one. V interval is a number and the value is 15. And now let's make our check. If our new salary will be more than 15% high of the related department's average salary, we will raise an application error and prevent that operation. Let's do it. If new dot salary is greater than average depth salaries with the index of new dot department ID times V interval divided by 100, then raise application error let's write a number like that and our message. A raise cannot be, let's concatenate that with the V interval and let's continue writing percent higher than its department's average, and our end if. As we raised an application error, if this error is raised, this after statement section will not be executed. If this section is executed, that means there is no problem. All the updates or inserts are done successfully. So we can print a message for it. Let's write all the changes are done successfully. Great. Now our compound trigger is ready. What did we do in this trigger? In the before statement trigger, we got the average salaries of each department into the associative array that we created. With this way, we will perform the checks much faster. How? Let's say our update statement will update 100 rows. If we try to get the average salary of that specific department in each update, we will be queried from the database for 100 times. And this will decrease the performance. Instead, we got the whole averages into our memory. And then in the updates, we get them from the memory much faster because getting the data from the database disk will be much slower than getting from the memory. And since we can easily get the average salaries much faster with using their indexes, it will increase the performance so much. We know that we can easily get the related average salaries from our associative array by using the department ID column. This is a great usage for the performance. In the same trigger, we shared that collection with different sections. And so we prevented the high salary increases within our after each row section. This is really useful. Great. Now let's compile it and test our trigger. Now let's open up the worksheet and make an update. Let's first make an update on the salary with a low increase. update employees copy, set salary is equal to salary plus 5, where employee ID is equal to, let's say, 154. Now let's run it. Oops, I think I had a mistake. Let me check it. Now we have a mistake in here. We need to write average department salaries plus this calculation. Now let's recompile it. And now let's run the update command again. As you can see, since the new salary is not over 15% higher than the average salary of its department, our update happened successfully. And since everything is fine, our after statement section has also executed and our message is printed on the screen. So now, let's update the increase with 50,000. And now let's run it again. As you can see, this time our trigger prevented this update and raised an exception with the specific message that we have written. Besides, since an exception occurred before the after statement section, this section is not executed and our message is not printed. That means our trigger works pretty fine. Alright, actually we can use the compound triggers for specifying the order of the trigger actions easily by collecting them into one trigger, or using the variables between each other, or for increasing the performance with a way like we did in this example. But the programmers generally use the compound triggers mostly for handling the mutating table errors. We will continue creating the compound triggers within the mutating table errors in the next lecture. But this does not mean that compound triggers are used only for the mutating table errors. If you know compound triggers well, you can increase the performance and make your triggers more stable. And you can make the order of different triggering events much easier with using the compound triggers. Alright, now you know why and how to create the compound triggers. So this is the end of this lecture. See you in the next lectures.